Hello students, let us read the question. A battery with the potential V across it is connected to a combination of two identical resistors and then has a current I through it. What are the potential differences across and current through either resistor if the resistors are in parallel? So the key concept involved here is the Kirchhoff's voltage law. By using this Kirchhoff's voltage law, we are going to find out the expressions for parallel combination resistors resistors. Let us first understand how we use Kirchhoff's voltage law in a loop. Let us suppose this is a battery of voltage V naught and the current I is flowing through it. Two resistors R1 and R2 are connected in series across the battery. So, and this point is named as V reference. The voltage of this point is V reference. Now let us write the voltage in this loop. In this loop, we can write this point voltage is V reference. If we reach here, the voltage will increase because of the battery, and we can add this voltage V naught. And if we move further, there will be some voltage drop across the resistor R1 and R2, which will be equal to I into R1 minus I into R2, and finally we will reach back to the voltage V reference. Finally we will reach to this point. This will be equal to 0. So the total voltage across the total voltage in a loop is always equal to 0 as per the Kirchhoff's voltage law. Let us start the question. In the question, we are given two resistors which are identical but connected in parallel. They are put across a battery of voltage V naught and the current through the battery is I. Let us suppose the current through this branch is I1 and through this branch is I2. Now we will apply KVL through two loops. First loop is this. This one is the first loop, which includes the branch through which the I2 current is flowing, and the second loop is this through the branch where the I1 current is flowing. So let us apply KVL in branch 1. In branch 1, let us suppose this is V reference. We can write V reference plus V naught minus I2 R minus V reference is equal to 0. From here we can write V naught equal to I2 R, which is nothing. The value of I2 is equal to V naught upon R. This is the value of I1. Similarly, let us apply KVL in loop 1. We can write from here, this is V reference plus V naught minus voltage drop across this branch through which the current I1 is flowing. I1 into R minus V reference is equal to 0. So from here we can write the value of I equal to V naught upon R. This is our equation 2. This one is the equation number 1. This is equation number 2. From equation number 1 and 2, we see that the value of I is equal to I2, which is equal to V naught upon R. And from the circuit we can easily see that the value of I is equal to I1 plus I2 because of the current I is divided into these two branches. So here we can write that the value of I1 equal to I2 is equal to V naught upon R, and these currents are divided equally, so we can write I upon 2. The value is I upon 2. Now we are capable to write the final answer. First one, the question was the voltage drop across two resistors. So from here we can see that the voltage drop across resistor R is equal to V naught, and the other resistor R is also equal to V naught. So the voltage drop across resistors is equal to V naught. And the second question is, what is the value of I1 and I2? Both I1 and I2 are equal, and that is equal to I upon 2. Thank you so much.